Now, what we're going to learn in this video is we're going to learn how to solve a quadratic equation by the factorization method, or by factorizing. So this is a quadratic. A quadratic is a curved line. This shape is called a parabola. And we can actually use this to model situations in the real world. Now, what I'm going to show you is, so this is the equation of a quadratic, or the quadratic function. And we can actually solve a quadratic equation. And this is a quadratic equation. Now, it's a quadratic equation because its sum expression equals 0. So what we're actually doing when we're trying to solve a quadratic equation is we're trying to find the value of x that makes this equation true. So some number squared plus 7 lots of some number plus 12 adds up to 0. So we're going to use this method here. We're going to make one side of our equation 0. Well, one side already is 0, so we don't need to do anything. We're then going to fully factorize the other side. So remember, when factorizing, we need two numbers that multiply to give us the n number, and two numbers that add to give 7. So 12, we have a couple different combinations. We could either have, well, we could have 12 and 1. We could have 6 and 2. Or we could have 3 and 4. Now, which one of these three combinations adds to give us 7? Must be the 3 and the 4. So then we can write our equation in double brackets, because we're going to have x plus 3, x plus 4 equals 0. Now we could use FOIL, and we could expand this back out. X times x is x squared. X times 4 is 4x. 3 times x is 3x. And 4x plus 3x is 7x, like required. And 3 times 4 is 12. But I'm not going to do that in pen, but I'm just going to show you that it works. So we've now factorized this. Now, so we've done step 2. We've fully factorized the other side. Now we're going to use the Null Factor Law to write out two equations. Now the Null Factor Law is basically that if you have some number multiplied by some other number, and that equals 0, well then either A is equal to 0, or B must be equal to 0. Now, so what I'm saying is the Null Factor Law to write two equations. So either x plus 3 is going to be equal to 0, or x plus 4 is going to be equal to 0. And then our final step is to solve the two equations. Now, the way that I'm going to solve this is, if you want to get x by itself, we've got plus 3, we need to do the opposite. So we're going to take 3 from both sides. They'll cancel out. We'll be left with x equals negative 3. And then here, we want to get x by itself, so we're going to do the opposite of plusing 4. We're going to take 4 from both sides. So we're going to have x equals negative 4. So these are the solutions to our equations. So if we substituted negative 3 into here, so we're going to have negative 3 lots squared plus 7 lots of negative 3 plus 12. And if we calculate this, well, negative 3 squared means negative 3 times negative 3, which is 9. 7 times negative 3 is negative 21. And 12. If we add all these three numbers together, well, let's do 9 plus 12. That's easier. That's 21. And 21 take 21 is 0. So negative 3 is a solution to this equation. Now, we could have done that by trial and error, but that would have been painful. But through factorizing, we found the solutions quite easily. And if I did this exact same thing with negative 4, if I chucked negative 4 into here, let's just do it. If we chucked in negative 4 squared plus 7 lots of negative 4 plus 12, well, I'm going to get negative 4 times negative 4, which is positive 16. And 7 lots of negative 4 is negative 28 plus 12. And if I add the 16 and the 12, I get 28. Subtract the 28, I'll get 0. So negative 4 is a solution too. So this equation here, this quadratic equation, has two solutions. It has negative 3 and negative 4. Now, the way that we can check, this has meaning. So remember, this is a quadratic. This looks like this. This equation, this function, looks like this. This is a quadratic function, okay? And it has a graph. Now, what we can do is, we can actually see on our graph, now the graph corresponds, these solutions, -3 and -4, they correspond to our x-intercepts, okay? So these solutions are our x-intercepts, -3 and -4. And the reason why this works is because our x-intercepts occur when our y is equal to 0. So when our y values are equal to 0, our x-intercepts are -4 and -3. So what we've actually done is we've made y equal to 0. And then we actually found the x-intercepts. So we'll do one more example to make sure it makes sense. So one side, here's our equation. We're going to make one side of your equation 0. So we're going to have x squared take 2x take 15 equals 0. We're then going to fully factorize this. So we need two numbers that multiply to give you -15 and add to give -2. So 15, well, we could have 15 and 1, or we could have 5 and 3. Now they need to have a difference of 2, so this is way too big. So it's going to be 5 and 3. Now we need to work out whether it's, one of them has to be negative, because we're going to get -15, and the only way we can get them to multiply to -15 is if it's one of these two is negative. Now, is it going to be 5 plus -3, or 5 take 3? That'll give us 2, so no. What about -5 plus 3? That'll give us -2. So it's going to be x take 5, x plus 3. So we've factorized it. We're now going to use the Null Factor Law. So x take 5 equals 0, or x plus 3 equals 0. And then, whoops, I didn't mean to have the brackets. Then we're going to solve these. So we have x take 5, so we're going to do the opposite process, which is plussing 5 to both sides of the equation. They'll cancel and we'll be left with x equals 5. Or, and on this equation, we're going to take 3 from both sides. So we're going to be left with x equals -3. So these are our solutions. And if we were to graph this quadratic, our x-intercept should be 5 and -3. And they are 5 and -3. So that's how you can solve quadratic equations by factorizing. Cheers.